Hey guys, welcome to this session. Our topic is static electricity, and today subtopic will be the capacitance. And the first video discussed the conductors and the insulators. So let's discuss about the capacitance. Now, capacitance, you have to know the concept of capacitance. So let's start with the concept of capacitance. Capacitance, basically, this is the ability of a capacitor that is an instrument or device that is used to store the charges. So capacitance is the ability of this device, a capacitor, to store charges. Now, capacitance basically is the ratio between the quantity of charges stored and the potential difference across the place of the capacitor. Now, it can be shown mathematically. Capacitance equals to quantity of charge on plates, that is shortly Q upon potential difference across the plates, that is V. So shortly we can say Q over V is what equals to capacitance. Or also you can say that if you post the application, making Q the subject, that is the quantity of charge on plates, then Q will be equal to CV, that is quantity of charge on plates equals to capacitance times C, the potential difference across the plates, that is Q equals to CV. Now, this means that the quantity of charges increases with the increase in the potential difference CD across the place. This means that the quantity of charge is direct proportional to the potential difference across the place. Now, the SI unit for capacitance is this farads. The other units include the microfarads, picofarads, and the nanofarads. Uh, Basically, the definition of a farad is the capacitance of the body or of a conductor, that is the potential, that its potential difference can be changed by 1 volt by a charge of 1 coulomb. So that's the definition of a farad. It's the capacitance of a conductor that its potential difference can be changed by 1 volt by a charge of 1 coulomb. Now, example, let's take an example. Calculate the capacitance of the capacitor if the cell connected to it as a 1.5 volt when the charge is 120 coulombs. Now, basically from the question, the data given is that first the potential difference, that is V equals 1.5 volts, the quantity of charge Q equals 120. Now, applying the formula that we have seen before, that C equals to Q over V, so Q will be equal to 120 divided by 1.5, then you get our answer simply, that is 118.5 farad. Now, so the capacitance of this capacitor is the 118.5 farads. Now, let's see the factors affecting the uh, factors that affect the capacitance. Now, there can be various factors that affect the amount or the ability of the capacitor to store charge. Now, the following are just few of the factors that affects the ability of the capacitors, simply the capacitance. Now, the area of the plates. So basically, the area that covers the plates will determine also the amount of storing of charge. So basically, the amount of storing charge is very proportional to the area of the plates. So if the area of the plates is small, then the capacitance will be small. If the area is large, it means also the capacitance will be large. The second one is the distance between the plates. Now, this we're talking about the distance that is given between or where these plates are set apart. So if the plates are set apart to a certain kind of a distance, will also determine the amount of storing of charge, that is the capacitance. And the last one, the ability of the dielectric to support electrostatic forces. So the ability of this direct material to support the electrostatic forces will also determine the amount of storing of the charges. So basically, we've seen all these three factors affecting the capacitance. So thank you guys for listening. I hope it's clear. We've seen the concept of capacitance. We've seen the mathematical presentation of finding the capacitance in the. We've seen an example. And just you've seen the various factors that affects the capacitance of conductor. Thank you.